In this lesson, what we're going to start doing is solving trigonomic equations. I am going to give you a variable that is going to be linked to a trig function, and we are going to solve it as if it was a linear equation by factoring quadratic formula and then by using our trigonomic identities. Okay, so remember, to solve an equation, we want to get a variable by itself. It's just kind of amazing that we haven't done a lot of solving equations. So to get x by itself, I'm going to use inverse operations. First thing I'm going to do is subtract 1 from both sides. So I'm going to get 2x equals negative 1. Then I'm going to divide both sides by positive 2, and I'll get negative 1/2. Now we can do this exact same thing with trigonometric functions. We can do it if it's one trig function all by itself. So let's go ahead and solve this. Let's get what I'm solving it. I want to get theta. That's my variable by itself. And we want to do it from 0 to 360 degrees. So my answer is going to be in degrees. So I'm going to take this equation. I'm going to solve it just like I did the last one. I am going to subtract 1 from both sides. So I'm going to say 2 sine theta equals negative 1. And then we are going to get the sine of theta equals negative 1/2. I need to figure out what theta is. So to figure out what theta is, I'm going to take the inverse sine of negative 1/2, and that'll tell me theta. Well, when we are looking at our unit circle from 0 to 360, where is sine negative 1/2? Well, that's going to be here, because sine is y, so it goes down, and it's going to be here. So it's going to be the point radical 3 over 2 and negative 1/2. And over here we're going to get negative radical 3 over 2 and negative 1/2. Boom. My answer is in degrees, so my reference angle in both cases is 30 degrees. So I'm going to go 30 degrees down from the x-axis in both cases. So for this first one, it's going to be 180 degrees plus 30 degrees. So that will be 210. And then in my second one, we are going to do 360 minus 30 degrees. And that gives me 330 degrees. So that's what theta is. So my answer set for theta, we're going to write a brace. And we are going to say 210 degrees, comma, 330 degrees. And we'll end our brace. So that is my answer set. That is how we show more than one answer at a time. What if I wanted to show all the solutions of theta? Remember, we're talking that we're on a circle. So our first answer was at 210 degrees. Our second answer was at 330 degrees. Well, we can take this 210 degrees and we can add a complete rotation of our circle to it. So we can take 210 and we can add another 360 degrees. We can take our 330 degrees and also add 360 degrees. And we're going to say where n is an integer. So 210 degrees plus 360, or 330 plus 360n, and that gives us all of our solutions because we can keep going around and around our circle. And because n is an integer, we can also do negative degrees. We can solve our sine and our cosine and our tangent functions. As long as you know how to use your trig, your graphing calculator, you can plug this in. Notice I got rid of the 0 and I said y equals, and then you can see your answers on your graphing utility. And this is a great way to help you double check your answers. Notice the 210 happens every 360 degrees to the right, and so does the 330. It keeps going, on and on and on and on forever, adding 360 degrees every time. Well, it's not always going to be a linear equation. Sometimes we're going to do some factoring. So remember, to factor anything, why I know I want to factor this is I have an x squared and I have a y. So the first thing I'm going to do when we factor is make this equation equal 0. So I am going to subtract y from both sides of my equation so it equals 0. Then I am going to factor out a greatest common factor, and that's going to leave me 4x squared minus 1. That equals 0. This is the difference of squares, so it factors to 2x minus 1 and 2x plus 1. When we are multiplying multiple terms together and the answer is 0, what we know is at least one of these has to be 0. So any number of them could be equal to 0. So we're going to find out what all these x values are. So we know y equals 0. Here we would have 2x equals 1. So x would equal 1/2. I would subtract 1 in this case, and I would divide by 2. And there are my 3 answers. I have an answer for y and two answers for x. And x is going to have 2 answers because of that x squared. Now, we can do the same thing with trig. We can still solve by factoring and that zero product property. So if I have cosine theta times cotangent theta equals negative cosine theta, what I can do is I notice that I have more than one trig function, so I am going to make the entire equation equal 0 so I can factor. I'm going to go ahead, my factoring, I'm going to take out the GCF, which in this case is a cosine theta, and that's going to leave me with cotangent theta plus 1 equals 0. So we know cosine theta equals 0. I also know cotangent theta plus 1 equals 0. Now we are going to use our inverse trig operations to get these by themselves. So we are going to say that the inverse cosine or arc cosine of 0 equals theta. Subtract 1 from both sides. So here we're going to get cotangent theta equals -1. So the inverse or arc cotangent of -1 is theta. So when we are solving these, we're going to solve them both for cosine and tangent. So when I'm looking at my cosine function, when we're looking at the cosine function, where is cosine 0? Here and here. And if you remember at the top, we said we're going to do it in degrees. So it's at 90 degrees and 270 degrees because we want to do one full rotation of our circle. Now we also want to find cotangent of -1. I'm sorry, not cotangent of -1, the arc cotangent of -1. When it's -1, that means x and y are going to, the sine and cosine are going to have the same value. That's my radical 2/2s, and those happen at pi/4, but they need to be in the negative quadrants. So that's going to be this one. And this is going to be 90 plus 45, which is 135. And we're also going to be in this one, which is 360 minus 45. And that's going to give me 315 degrees. So my answer set for this, we're going to do our brace. Because it said for one rotation, we're going to do 90 135 degrees, 270 degrees, and 315 degrees. We always like to put those in numerical order. Now, one mistake we want to avoid, if mistake might be a strong word. You might be tempted to divide both sides by cosine theta, and that turn, because hey, let's get all the cosines to one side. Please don't. If we had, we would have had the equation cotangent theta equals -1, and that would have just told us theta is 135 and 315. We would have left off our sine values. Alrighty, so our cosine values. We'd have left off our cosine values. So do not eliminate terms if we can help it. Let's take a look at example B. Now notice this answer we want in radians. So again, I've got a sine squared function and I've got cosine theta functions. So I am going to go ahead and see if I can get this to factor. So 2 sine squared theta cosine theta minus cosine theta equals 0. So I'm going to go ahead and I'm going to factor out the cosine theta. And so what I have left, I'm going to have 2 sine squared theta minus 1 equals 0. Set all my factors. In this case, it's only 2. We're going to set all the factors equal to 0 so we can solve them. This one still needs to be solved, so I'm going to add 1 to both sides. Divide by 2. Take the square root of both sides. So we are square rooting both top and bottom. So then we know the sine of theta is going to be both plus and minus radical 2 over 2. So solving this, let's take the inverse cosine of 0, and that's going to give me theta. So we are asking when, again, is cosine 0? Here and here. So we wanted our answer in radians this time. And then where will we have plus or minus radical 2? So we're going to do the inverse sine of plus or minus radical 2 over 2. And that's going to be my theta. When we look at our sines, where do those happen on our unit circle? Well, that's going to be at all of my pi over 4 reference angles. We're going to go pi over 4 all the way around. So all of my reference angles are going to be pi over 4. So that's going to be pi over 4, 3 pi over 4, pi plus, so 4 plus another, and 5 pi over 4, and then this one is going to be 7 pi over 4. Wow, lots of answers. So when we write our answer in our number set, we're going to write them from least to greatest. So pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, right here 3/2 pi, 3 pi over 2, and 7 pi over 4. And you a brace, not a parentheses, and this can always be verified by graphing. Alright, I know I didn't get to C. We will do C when we get together in class. So if you got any questions, please let me know.